And then just to make sure that I click on the recording as well, just so that we have backup. And then just to make sure that I click on the recording.
Start.
Yeah, we are exactly at 8:30. Let's just give a few more minutes. Let people join in.
Okay, give me a heads up when the recording starts, and I'll
Sure.
May I ask how many many times, how long I should leave for the Q&A?
Maybe
Yes.
10 minutes.
Yeah,
10
so
minutes? Okay.
Yeah.
the total slot time we have kept 45 minutes. So
Mhm.
you could speak for 35, keep 10 minutes for Q&A. That should be good.
And the Zoom meeting is only for us, right? So for five of us?
No,
And where is the...
there are attendees who are joining in. What you are seeing is the panelists.
So the audience will join the Zoom meeting?
Yeah, so
During-
they are already differentiated as panelists and attendees. So you should click on the attendees who are joining in.
Okay. I see that the 22 people there.
Yeah. I think we'll start in 1 more minute. So thanks everyone for joining in. Let's just give 1 more minute and then we will start with the introduction. Mohit, I think let's go ahead.
Sure. You want to start the recording?
Yes, done.
Okay. So, hello everyone. Welcome to the second day of Connections 2024. Thank you all for joining in. Today we will be having IPv6 track, and after the quick introduction to what INTC and IISOC is doing with IPv6, we'll have excellent set of talks from Devi and Tommy who have joined us today. Thank you for joining us today for this particular track. Before we get started with our speakers, I'll just like to give a quick introduction to what we have been doing with IPv6 at IISOC and INTC. Just to list out a few things very quickly, that plenty of activities have been happening jointly with IISOC and INTC. First of all, starting with at least 3 full phases of IPv6 webinars, which are also available on IISOC website and INTC website, where we got funding from APNIC, and we had these 3 sets of webinar series that we had. Also, dedicated focus was given on IPv6 and IoT and IPv6 and security. And then, apart from these webinar series, IISOC and INTC have been mentoring the faculty members and students at NITK. I am a faculty at NITK Surathkal, which happens to be in Mangalore, Karnataka state of India. And the primary activities that include NITK are, first of all, the IPv6 deployment. So we have a funded project, which is separate from the webinar series, which we had funded from APNIC. This is a project which is funded dedicated for IPv6 deployment only. And it has been totally led by NITK students. And we have been advised by INTC members, Nalini and Mike, and also from IISOC, we have been mentored by Dhruv. And we have a lot of students who are now getting involved also in writing the IETF drafts. Thanks again to the mentorship that has been coming over so many years from INTC and IISOC. We already have one of our draft in the last call. And then there are many other projects that the students are involved in. Some of them are listed below. For example, we are working on the DULT project We also have an implementation of the PDM, the RFC 8250 in the Linux kernel, which is an extension header for IPv6. And then we have been also exploring the eBPF deployment and performance. So all of this is a very interesting work that's being done at NITK, and we thank INTC and ISOC for their support. Just to give a quick glimpse of what is IPv6 deployment project and what are we currently doing. So the current status of the NITK Surathkal network, the campus in the university campus, is that we have around 45,000 plus terminals that are connected to the internet. We also have another campus coming up within the 40 kilometers range. So we'll have a new network which will be set up over there. And there's a quick overview about what is the current infrastructure, which includes 350 plus switches, 1,200 plus indoor-outdoor Wi-Fi access points, and all the other things which usually exist in the networks, which includes firewalls, switches, all the different services that run on top of it. The first step that we did is we, first of all, went ahead and took an IPv6 address block from our local internet registry. We have a /32 address now available, which was kind of mandatory for us to also proceed with the funding that we received. And thankfully now we have an ISP who is supporting us and who is already advertising our IPv6 block on their network. So we took quite some time and we were able to achieve this particular step. And then onwards, we started setting up basic testbed at NITK. This is a sample presentation of how our current testbed looks like. So we wanted to play with this particular testbed before we go ahead and start migrating our entire campus to IPv6. So we have 4 to 5 machines which have been dedicatedly put up running only IPv6. And we have leveraged our current network infrastructure to connect to the internet. And as I said, our ISP is already supporting the advertisement of our IPv6 block. So in the process of doing this entire exercise of migrating the university campus network to IPv6, another thing we are doing is we are documenting every step that we are taking so that towards the end of the project, we can have one consolidated document which kind of helps other universities or enterprises to see how we did it, and possibly it could help them also migrate their network. So for example, once we have completed setting up this testbed at NITK, we have now documented it thoroughly as to how we did it and what challenges we faced. And we have described those challenges in detail along with how we were able to fix it. Sometimes we had to resort to looking at packet traces in detail to understand what's happening. And then we went ahead and started fixing those issues. So that's something that students have been doing very actively. And these are undergraduate, postgraduate, and PhD students, all of them who are involved in this exercise of migrating the campus network. Last year, in the month of March, we had a workshop at NITK on IPv6 deployment. About 92 participants from different parts of India participated in it. I take this opportunity to also announce that a similar workshop has been planned in this March as well. I'll be sharing the link for registration once I complete my introduction section here. I'll put it up in the chat box so that if anybody is interested, you can take a look at what are the contents that we are going to cover. In this year, the dates are from March 9th to 13th. And soon you all will have that link once I complete my session. The same testbed which I discussed about it. So we had 2 of our students. This is a picture that we have taken while one of the students, Vanessa Fernandez, is presenting our IPv6 deployment effort in the V6 Ops at the recently concluded ITF in Prague, where we went and showed how we have set up the testbed. And another interesting thing, we have already migrated our MIS of the university, which we call it as IRIS, and we presented statistics of 40 days of IPv6 enabling, and we showcased that already 49.5% of the traffic that hits our MIS from outside NITK already was on IPv6. So now this was done in November. We also have the recent statistics that we are going to present in the upcoming APNIC 57. Also, we are going to update the statistics for the ITF that's happening in Brisbane, where we will be presenting the statistics of 6 months as to how we see the traffic pattern, which operating systems are allowing IPv6, where we are finding issues, and we are fixing one by one. So this is another student of ours. You can see Kavya Bhatt, who was also there at ITF in Prague, and she presented the statistics of the project that we are doing. I would like to invite all of you to join IISOC and INTC. There are a fantastic set of activities that are happening. IPv6 is just one of the activities about which I spoke about. And here are the links. We'll be also putting all these links into the chat box for ease of access. And with that, I'm done with my introduction part of it. Yes, I'll pass it on from here to Nalini. Nalini, over to you, and I'll take care of the slides. So please let me know when you want me to move to the next slide.
Thanks so much, Mohit. Yes, please go to the next slide, and we'll get started with our great speakers. Okay, so the first thing is going to be Davey, who's going to talk about the implementation of IPv6 at Alibaba in China. You might know, of course, you probably have heard of Alibaba. It's one of the largest cloud companies in the world. Please do ask questions whenever you want. We're so happy to have Davey here with us. So Davey, why don't you go ahead and share your slides and take over.
Okay, thank you. I will share my screen. Can you see it?
Yes, we see it fine.
Okay. Hello, everyone. My name is David Song, and I'm from the Network Infrastructure team at Alibaba Cloud. I'm truly honored to be here today and to discuss the IPv6 practice within Alibaba. Firstly, I would like to take landscape in China, which we'll explore in the following slide. Many of you may aware that the Chinese government issued a substantial IPv6 commercial deployment program back in 2017. Today, we are excited to find that the remarkable increase in IPv6 adoption in terms of users, key apps and websites, as well as expanding share the portion of internet traffic observed over the last 3 and 4 years. From July 2019 to December 2023, the number of active IPv6 users increased from 208 million to 778 million. The portion of IPv6 traffic in mobile networks rose from nearly 1% to 16%. The portion of traffic in fixed network also increased from none to nearly 20%. Believe the figures tells a significant story. The entire internet community and ecosystem in China has made tremendous strides and concerted effort to achieve this milestone in IPv6 adoption. It's not easy in China, since China is not an English-speaking country like Japan and Korea. In addition, getting online with existing IPv6 websites and content like YouTube, Facebook isn't that straightforward for us. A lot depends on the local content providers. I'm very proud to say that Alibaba is right there at the heart of it all, and I'm excited to be part of this journey. Let me introduce the company I work for a little bit here. Alibaba started as a small web company. The company's mission is to make it easy to do business everywhere. Now Alibaba is famous for its e-commerce application, Taobao, Tmall, and AliExpress. It also has applications for entertainment, travel, messaging, working platform, and tools like Maps. It serves more than 1 billion users in China and 304 million international users out of China. Beyond that, Alibaba provides robust cloud infrastructure, which includes data centers, content delivery networks, DNS services, and various cloud solutions. This infrastructure supports many businesses, both small and large, allowing them to deploy their services and create applications on state-of-the-art cloud platform. You see, the challenge is clear. Transition, large-scale online services, cloud platform, network infrastructure of that size to IPv6 is daunting, particularly with IPv6 network still under deployment at that time on early stage 5 years ago. Let's just quick dive into why and how we initiated our IPv6 push at Alibaba. The motivations, the first is obvious that you see that IPv6 address fully exhausted and the trading price is increasing, it's soaring. So it's becoming a financial way for big companies and cloud providers. And secondly, that starting from the end of 2017, the Chinese government has been actively issue plans to encourage and boost IPv6 adoption in production network and services. We also are looking forward the potential of the IPv6, the innovation and new capabilities such as software-defined network with segment routing v6. We're hoping the IPv6 will bring and promised refined network services for applications. And the challenges is also obvious that the stability and the risk issue during the IPv6 transition for large scale on the services. Ensuring stability and high availability is very, very important. It's key for the online services. The second one is the legacy infrastructure. We need to ensure that the infrastructure involved with new capabilities and support new services, but we cannot pause for the IPv6 transition, which also brought the complexity and risks. At the start of our IPv6 shift in early 2018, the end-to-end network readiness for IPv6 in China lagged behind that of IPv4. That's the situation all the company faced. The network is not ready, and the application is planned to shift to IPv6. That's the situation in China at that time. Huge work on network and application mitigation to IPv6, and there are also some organization issues by organizing or coordinating 12 different business units and over 500 engineers. As an engineer, we're focused on some technical issues. First one is that how to migrate online services smoothly, regardless of the network situations. It's complex. How to decouple the upgrade process on both network and application. In both IETF and the engineering community, there are a lot of talk on the network transition, but a little little how to say the efforts or discussions open are publicly aware on the application layer and for the big platform to translate to IPv6. So how to decouple the two things are very important. The third is that as a technical, especially the network engineer, we are looking forward that IPv6 features will bring new promising scenarios, use cases, especially in the era of AI and machine learning age. So let's take a quick look at Alibaba's IPv6 adoption timeline. From 2012 to 2017, we are in the research and preparation phase. We run evaluations, experiments, and a few small-scale IPv6 trials, recognizing that IPv6 potential, but also saying it wasn't quite ready for the production network at that time. And between 2018 and 2019, we entered a phase of caution step by step. IPv6 integrations for our core application and infrastructure. This marked the beginning of small-scale commercial IPv6 adoption, as we saw an uptick in IPv6 active users. Over the past 4 years during which I joined this team, with gained experience and confidence, we have expanded the IPv6 across many Alps regions and our cloud platform. User numbers and IPv6 traffic have surged, signifying our transition to full IPv6 deployment. Recently, we hit 1 billion users, global users, and achieved over 19% IPv6 traffic portion, which we monitored weekly. Looking ahead, our goal is to provide IPv6 only capability to users and explore the potential of IPv6 and SRv6 use case in our DC network. To grasp how we enable IPv6 for online services, then let's look at a high-level architecture. If you are not a guy doing the app stuff, there are 3 components. The first one is the user-facing app, or you may use the browsers. The DNS and ISP network access network must support IPv6. We put significant effort to planning the rollout of IPv6 across our client apps, which we discuss later. We will later to focus on how the apps adapt the dual stack situation. The second one is that at the access point, the service access point here, IPv6 user connection are received. They undergo security checks, which have adapted to IPv6 new patterns. You know, IPv6 bring new security checks with the new threat informations. They are routed to the optimal servers that process the connections, depending on whether the backend services is IPv6 ready or not. We use either SLB 6.4 or SLB 6.6, which translate IPv6 packet into inner IPv4 or inner IPv6 packet. Vectors are handled like IPv6 addressing the context in the database, geolocation data, APIs interface, and address format checks, stuff like that. It was noting that in the SLB model, a TCP option carries the IPv6 address to backend server, increasing IP header size that is taken into the consideration because the MTU issue is noticeable. We also employ the proxy protocol for this. The third party, the cloud services, they mainly provide internal services cater to cloud VPN with VPC users. Some people believe that shifting these internal services to IPv6 can also alleviate the demand on IPv6 private addresses. I think the priority pushing IPv6 inside the cloud services, for example, like the control and management system, is not that high. Okay, from the cloud platform perspective, I would like to introduce on behalf of the cloud, Alibaba Cloud. We offer different solutions based on our user needs. The solution one is the proxy solution, utilizing Alibaba's global accelerators services. We have enabled IPv6 for public-facing access on Alibaba Cloud without needing to modify existing infrastructure of customers. This is ideal for users with services hosted in their own site. The solutions 2 and solution 3 is for the case that the customer deploy their services on Alibaba Cloud, and they can opt for SLB 6.4 or SLB 6.6, depending on their services is ready for IPv6 or not. Just like the previous slides I introduced. Alibaba Cloud now fully support dual stack operations. I also heard that some cloud provider provides the IPv6 only environment for the customers. But right now in China, we will not receive that requirement at the moment. But I think if the customers can deploy their services in pure IPv6, it's a good thing that we can gradually retire our IPv4 services and reduce that investment, right? Okay. After introducing the application view and cloud platform perspective, I would like to introduce the very key technical challenge that's how to smoothly migrate online services to IPv6. First of all, understanding the IPv6 network quality is crucial. So inside Alibaba, we have built a IPv6 measurement platform based on our application, based on our apps that are used by billions of people. At Alibaba, we here I will share some network performance in metrics on TCP success rates, TCP connection latency, and IPv6 coverage on both wireless and wired fixed network. By the end of 2023, from our monitoring in mobile network, the TCP success rate under IPv6 network is 98% on par with IPv4, but it falls to 7 to 80% in wired Wi-Fi connection. IPv6, the TCP connection latency is similar for both IPv6 and IPv4, around 50 to 60 milliseconds, with no significant difference observed. That is huge, how to say, achievement during the years to keep the performance of the latency. I think the coverage of IPv6 at the 2023, the wireless the network, I mean the 4G and 5G LTE network has more than 90% use that coverage. Well, while the Wi-Fi network lagged behind at around 28. So we can see the bottleneck of the current IPv6 deployment in China lies in the wired network, with legacy requirements such as the home Wi-Fi routers being a primary concern. Just before this meeting, my home Wi-Fi network cannot make me connected to the zone, so I'm not sure what happened. By the wired and the wireless, the mobile network is much more better performed than the wired network. The situation is more complicated than the wireless mobile network, I think. Yeah, from my observation, the rapid and widespread adoption of IPv6 in India can be attributed to the country's predominant use of wireless network. Am I right? I'm not sure. Please correct me. Okay. Addressing the issue of application capabilities in that network is very important. Our IPv6 measurement platform provides real-time location-specific data on network quality. In the beginning, we often we frequently face the issues, just like the IPv6 day people faced in Japan, that the IPv6 network is not ready, but your connection will fall back, and we're broken the net connection. And so to prevent the IPv6 connection issues in the beginning, in the early age of our IPv6 push, we implement an intelligent whitelisted approach for use user can access. Our strategy includes that the IPv6 network assessment to gauge quality from the client perspective. We continue do the measurement to ensure that the customer confidently to open to enable their apps to support to enable their IPv6 function. Many factors like the geolocation, operating system version, ISP network, and 4G or 5G or 3G information are taken into considerations at that time to form a refined intelligence scheduling, and the configuration and content delivery tailored to specific user groups, because the apps can communicate with the backend server, the control system, so they can open the IPv6 capability due to the intelligent scheduling. We also implement the improved Happy Eyeballs algorithm. I'm also very happy to hear the speakers after me introduce the Happy Eyeballs version 3. So I'm very looking forward to that. At that time, we also improved the Happy Eyeballs, not the pure Happy Eyeballs algorithm to the Taobao, for example. We send the A and quarter A records in the same time. We get the priority, the address list with the priority from the servers, pushed by the servers, and we keep and tracking the stateful triples on IP protocol other than just tracking IP. All of this is to keep this a very cautious approach to make our service migration smoothly. But you know, one of metrics that government pay attention to is that the traffic, right? The traffic portion. So to boost IPv traffic, in order to boost IPv traffic on the Taobao app, we took strategic steps. In the beginning, we dropped an IPv6 enablement list covering over 500 Taobao domains, prioritizing CDN domains and domains in the first page, the front page of apps. In addition, the apps prefetch the IPv6 address where possible. Our app's behavior in a dual stack environment also has evolved over time. Initially, we imposed the 30-minute penalty for the IPv6 finishes to encourage stability. Later, to increase IPv6 usage, the app defaulted to IPv6 with switch to IPv4 if any issues arose. This worked well on mobile network, but saw frequent fallback with unstable wired network. Currently, we implement a Happy Eyeball approach, racing IPv4 against IPv6 with a 300 milliseconds delay for connection attempts. This tactics has propelled many Alibaba applications, including Taobao, to reach at 95% IPv6 traffic ratio on a single apps. We test we test a phone with our apps, and we get a statistic of IPv6 traffic, and we notice that we reached the 95% of traffic ratios under the dual stack network environment. Yeah. Besides the large scale online service integration, I also would like to introduce a little bit on the ongoing IPv6 innovations in Alibaba predictable network. As you know, with the emerging AI and machine learning new workload, data center network is evolving rapidly. A large-scaled high performance network becomes crucial to support a large scale AI cluster. You can find talks on the Alibaba predictable network when you search it on Google for more information. Here I highlight the 3 words: single chip white box, IPv6 only with segment routing, programmability. As we are talking IPv6 this session today, I just briefly introduce how we use IPv6 in this situation, in this scenario. In DC network, people may know that the switch is simple, but the backbone network, I mean, the router is more complicated. Besides IPv4, there are a lot of legacy protocols, as you know, the MPLS, the traffic engineering, the VPN, etc. Our idea is to simplify the protocol first. We simplified and converged all the protocol to IPv6 only, and use SRv6 to provide network functions. Just use SRv6 to take place the MPLS, the VPN protocols. So simplicities provided by IPv6 is the most important reason for us to adopt IPv6 inside our DC network. That's the one important reasons. There are others. For example, nowadays in the cloud computing network is distributed. You know, there are millions of servers located in tons of thousands of locations, or even more edge locations. That is different from the central cloud computing networks. The scale of cross-domain traffic engineering is much larger than the time of central cloud computing network. So another reason to use segment routing IPv6 is to provide fine-grained traffic service SLA, because different customers may have different requirements for the network performance. For example, one customer may require that the traffic travel from one particular region or country or ISP due to their different considerations. So we need a fine-grained, more specific capability to cater to the diverse customer. So we adopt. So that's another reason to use IPv6 in the DC. We adopt SRv6, the segment routing v6, as our strategy for the one network's evolution. So if you are interested on that part, you can check that on the Google for more information. Yeah, I go through my slides very quickly. And before I finish my talk, I would like to look back to one of my posts in the Epinic blog from the 2017 about IPv6 in China before China government's IPv6 program. Here is where we stand 7 years on. At positive deployment that we established a fully concerted IPv6 protectional network on par with IPv4, especially in the mobile network. You know, 7 years ago, the IPv6 network is an island. It's not fully connected. That's the situation before the IPv6 program issued. Not to mention that the performance, the IPv6 network performance. Now the IPv6 performance rivals or exceeds the IPv4 in certain Alibaba tests. So that's very exciting. That's the key. The IPv6 should provide something, right, special or not bad, not better than the IPv4, right? There is one point I'm not listed here is that according to our estimation, there were extra 5% of a traffic cost. I mean the cost of bandwidth of the IVC or CDN. You know, the bandwidth consuming applications and infrastructure. They were the IPv6 will bring nearly 5% lift of the traffic consuming. So that's also a burden, also a speed bump, I think, for the customer to choose the IPv6, to shift the IPv6 traffic. I'm not sure what the feedback of our friends in India or in US. What's your reaction, or what's the different policies? I'm very curious on that. We are talking about with authorities and with ISPs recently to reduce the to give a some discount on the traffic, the price, so that we can encourage more IPv6 the usage. The IPv6 traffic surged to over 80% on wireless and nearly 20 on fixed network. That's a huge progress. Over 90% of Alibaba app users access IPv6 on wireless network. We can also observe that the dual stack adoption has been confirmed as effective strategy, because years ago, 7 years ago, or more, 10 years ago, a lot of people spend a huge amount of effort discussing the transition protocol, transition solutions. So the dual stack is still confirmed as the effective strategy. The widespread deployment of IPv6 and segment v6, segment routing v6 in data center networks is also a positive deployment. And there also challenges remains. We noticed that the wild network, their last mile connectivity issues persist in IPv6 with poor performance and poor IPv6 coverage, the dual stack coverage in wired fixed network. That's very hard situations in China, as far as I know. Although protocol, the dual stack hadn't reduced the IPv4 address demand, and also the financial burden of IPv4 trade still exists. Because with the long-term legacy network reliance, there's no clear plan, a pathway to retire before, as far as I can see. So that's a problem, and the challenges I would like to propose to the community, and I also want to hear from you. What's your feedback? Okay. In conclusion, we observe that IPv6 is now fully mature globally. Alibaba support is across our infrastructure, empowering 1 billion global users, as I introduced, from different phase-based approach. For large scale services, stability and risk management are key during the upgrades. Special effort and consideration should be taken. We found that modernizing old infrastructure is complex. It's easy to integrate IPv6 from the start. I think it's been told many times. It's good news to notice that there are new momentums. I mean, the IPv6 is not just only a large pool of address. In Alibaba, the practice, the IPv6 is used to simplify the network and boost efficiency, and provide additional services to our customers. So that's the yeah, that's all for my presentation. Thank you.
Thank you so much, Davey. Let me, if you can, maybe you can stop sharing your screen. That would be great. Let me take some questions. If you have questions, please go ahead and enter them into the chat box, and then I will go ahead and ask some questions too. There's one question already. Is on the impact of IPv6 on cloud, since cloud is the new technology, and another one in the chat, I think, about some companies such as Amazon AWS are charging for IPv4 addresses, especially if you get fixed or elastic. That's what they call them in AWS. Do you guys do that? So it's a bunch of questions all at once. But so what is your thoughts?
Okay, I heard that the questions in the chat box. What real impact IPv6 will have? So I mean, you mentioned that what's the benefit that IPv6 will have, right? From the past experience, the IPv6 is not it's not a new product like the Vision Pro, right? Recently launched. It's not the new product that we can buy it and get the benefits with in a second, right? It's not that. It's a fundamental IP protocol evolution. It takes more than 20 years or 13 years. So if you ask the benefits IPv6 bring, I would like to say that we do see that IPv6 is the right direction that Intel will involve, and as the quicker you take it, the next pain you will have. But we also observe that there are new situations and use cases that really bring benefits to our users, just like I introduced that to simplify network protocol stack, and also provide the service how to say different services, different SLAs to different services to the customers. And we also use the IPv6 to take place the VTNAM. You know, in cloud there are many, there are multi-tenant environment. The traditional approach is to use the VTNAM in the virtualization network. Right now we are testing. We're actually not the testing. We already deployed the IPv6 to use the seed of the segment routing of v6 to take place the function of VTNAM works. So actually the IPv6 is can take place the IPv4 and without the limitation of the address pool exhaustions, but also provide the features. I think I can answer that like that. Okay.
Oh, thanks so much. So there's, I think, one participant who wants to speak. I'll see if I can unmute him. But also too is there's a question about auto provisioning. Let me read that to you. Do you feel that IPv6 auto provisioning, I assume they mean Slack. I think they mean Slack. Does that bring in day zero security issues?
I'm not sure that maybe I'm not get the problem that IPv6 auto provisioning are related to the data security. I'm not a security guy, but in the cloud environment, the IPv6 address, if I'm correct, understand your questions, you auto provisioning is the auto address allocation to provisioning to all the services, all the service, right? In the DC situations, all the servers are pre-configured with with how to say this, static configuration. Not use the protocol to provisionize the address for the servers or for the virtual machines. So I'm not very get the questions how it's related to the data security. I'm sorry.
Yes,
It
yes.
can be enterprise and campus. At that time, yeah, I do not have any right answers to this question. Sorry.
Yeah, sure. No, thank you, Davey. Let me take a shot at this too. I'm not, but I can sort of see your confusion. It's not clear to me that those two issues are related. I think day zero vulnerabilities and stateless auto configuration, if that's what the person means, they're in IETF talk what we call orthogonal. I don't know that those two issues are related. I mean, you can have day zero vulnerabilities for many other reasons. It's not clear to me why you would pick stateless auto configuration per se as having to do with it. I mean, in my mind, stateless auto configuration, one of the things that can have a problem with is, well, it's kind of interesting to me that you give static addresses to your clients as well. Yeah, that's very interesting. I assume with DHCP, or do you just you do DHCPv6? No. Oh, very, very interesting. Yeah, so I think that's very, I would love to have a different discussion. Yeah. Yes, would love to have a different discussion on how you actually give addressing on that. But as I say, I don't know that those two are related. Let me say, I think Mike had a question. Mike, I believe you're unmuted now. So go ahead.
All right, testing
great.
1 2 3. Testing
Yep,
1 2 3. Can you hear me?
Yes,
Okay.
we can hear you.
Yes.
My first question isn't a question. I just want to thank Davey for an excellent presentation on behalf of all enterprises. This is just fantastic, and I hope you keep doing it. And just thank you. I have a couple what I think are pretty brief questions. I would like to endorse what Nalini said. Is if you would do a follow-up with us on addressing. It sounds like you're doing a lot of static, and if especially if that's for the clients, that would be an interesting area to explore. And then why you chose not to use DHCP or Slack, that would be a great discussion to have. But just endorsing what Nalini said there. And a couple of my quick questions are, how big of an address block did you get, or do you have multiple, and did you do it across regions?
Sorry, the question.
How big is your prefix? You know, what IPv6 prefix did you get? That's your question, right, Mike?
Yes, it is. Or if you got multiple across regions, or
Okay. There are two different views. One is from the the VPC. If you order one version, the virtual machines, it says, like, for example, you you can be it can be provide /64 prefix /64, yes. And if you are that's the perspective of the end users, I mean the cloud, the ECS users. If you are for example, you would like to add one server, physical server to the DC, I have done that before. I will be allocated to the /48 as far as I remember, 48 /48 prefix for my cluster of that the server in one available zone. I mean one region. Yeah, that's how
I'm
we.
going to go on to it. Yeah, thank you for that. I'm going to go on to a different question. When you first started, and it sounded like you guys started IPv6 back in 2012, so kudos for you to be such an early adopter. When you first started to get interested in it, what was your reason or business case? If you can remember that far back.
You mean in the 2012?
Yeah, when you first decided your company started to look at IPv6.
Yeah.
That seems to be a stumbling block for a lot of us. Why should we get started?
Yeah, 2012 is it's the IPv6 launch, right? The year of the IPv6 launch, as far as I know. Alibaba, I was not here in Alibaba at that time.
It predates you then, okay.
Yes. As far as I know, at that time, internet companies are doing some trials to make their website. Some of the first page of the websites to migrate to enable their DNS firstly, and then the website summer page can be accessed from V6. I think the most motivation behind is that the Chinese government set up some trials, some projects to encourage the ISPs and ICP to do some trials at that time. I think, yeah.
Okay,
there are no user cases. You know, in the if you remember my first picture of there is a track of the traffic portion, right? In the early 2019, there nearly none, very little traffic in the backbone. So before 2017, all the IPv6 activities in China, as far as I know, are research and trials, pilot, not connected, fully connected. Yeah, there are some funding support for the activities. Yeah, that's the situation.
Nalini, can I ask one more question, or have I used up too much time already?
No, you can ask one more. I have one more from someone else. But you know what? I'm gonna burst in here because I can't stand it. So I'm looking at your financial institution in China. I assume that's enterprise, right? Say like Bank of China, somebody like that. The reason I ask is that is the worst problem that we have. We cannot get enterprise to move, you know, like our financial and Michael actually works for a very large insurance company. And same in India too, I will say definitely is this is why like what Mohit is doing with NITK is so important, is that our enterprises, our end user large enterprises are refusing to move. So am I misinterpreting your graph?
You mean this graph?
Did I misunderstand? What did I misunderstand that when you say financial institution in China, you mean like
the bank,
you mean Bank of China,
the stock, yeah.
And they are 100% convert.
from the website, there's data source. From the data source, they are reported 1%. Yeah, 100%.
Oh, their websites are 100%, but their internal.
Yeah, if you yeah, we are talking about the IPv6, the adoption of traffic, or the user face interface, the traffic.
Okay.
The internal. We are questioning. Now we are questioning what. Should we adopt the IPv6 inside of the network or inside of the system? It's a question. It's take us more than half year, nearly 1 year, to try to mitigate our, we have very complex control and management system for each applications in the DC network platform. We once tried to mitigate the system that's inside of the system to IPv6. We found it's very difficult, very huge work to. There are a lot of dependency on other middleware or some database issues. It takes a lot of time. We found nowhere. We found us nowhere finally. So now we focus on the user interface, and the IP protocol is the protocol to connect the network, right? So why to uptake the IPv6 inside of your home, inside of a network? Only because you think it's necessary, I think.
Well, thank the Lord. I mean, because that's exactly our experience. And so what I'm thinking is how you found something we never found. And because Michael and I have been trying for over 10 years, I still think is a good idea. We can have offline discussion, but thank the Lord is like you guys are okay. So I understand. But good. Okay, so this is wonderful. Thank you so much. Would love to have lots of more discussion. Let's get on to our happy eyeballs talk. Thank you so much, David. Maybe you can stop sharing and then yeah, thank you so much. Yeah, Mohit, maybe you can bring up the introduction for Tommy.
Yeah, just give me a minute. All right, just give me a second. Okay, you should be able to see this.
Yes, thank you so much. Yes. Okay, so now we're going to talk about Happy Eyeballs version 3. This is the newest version of Happy Eyeballs, and Tommy has a draft at the IETF on this. And Tommy is at Apple, and he is very active at the IETF. He's a co-chair of a number of groups, including IPPM. With that, thank you so much. And let's get to your session. Looking very forward to it, Tommy. Thank you for speaking.
Great. Yeah, thank you. All right, let me share my slides. Okay. Is that coming through for everyone?
That's perfect. Thank you.
All right. Great. So hello, everyone, and thank you for the introduction. So I'm Tommy Pauly, and today I'm going to be talking to you about Happy Eyeballs, and I know this was brought up in the last talk, so hopefully we can dig in a bit more to understand the background of what it is, and then also kind of the new changes we're coming up with here. And what I want you to get out of this is, if you're going to be participating in the IETF or other discussions, there are things where you can contribute and participate in this discussion and help shape how we do IPv6 adoption and drive that from the client. All right, so let's dive in. So first, what is Happy Eyeballs? It's a funny name. I definitely know that. It's an algorithm that networking clients use when they are setting up connections to servers by host name. So like when they know a host name, a domain name, and they want to connect to it, it's a technique for setting up that connection that favors generally IPv6, but also ensures they have good connectivity. So it's designed to help the clients use IPv6 more often and more consistently, but critically to not get stuck or have user-facing issues if there is any brokenness for IPv6 support in the networks or the servers. Because as you'll see, the support for IPv6, while it is growing, is not always perfect as it's being deployed. And getting over that speed bump is really critical as part of actually making deployments successful. But before we go into the algorithm, I want to get back to some first principles here of why would a client want to use IPv6? And we know maybe why some network operators may want to do it, but from a client's perspective, what do they get out of it? What is in it for them? So maybe one option is because IPv6 is the future and it's new and shiny and better than IPv4. But that's not super compelling. It's not really all that new. It's maybe if you call 26 years old a new protocol, then great, but it's not that new and shiny. So this can't be the whole story. This is not enough incentive to move to it. Some of it actually is about performance, improved performance with IPv6. And this may be a bit surprising and a bit counterintuitive at times. I think the common first assumption would be that a longer packet header shouldn't really make things faster. It's like, oh, it's going to be a bigger packet, more bandwidth or whatever. But actually using IPv6 routes through a network and to servers is often better. And I think a lot of this correlates to faster network and server infrastructure. It's not because it is IPv6, but it's that the things that do support IPv6 are better. So just looking at some numbers that I've collected, this is just like worldwide traffic here. If we look at IPv6 connections to dual stack hosts, so hosts that support both IPv4 and IPv6, when the device is on a dual stack connected network, so they have the ability to send over both IPv4 and IPv6, we see like 120 milliseconds for a connection setup time on average for the 50th percentile, so the average there, and up to around 400 milliseconds at a 90th percentile. And when you compare that to times when we end up using IPv4 to connect to those dual stack hosts, and so this is a case where maybe that server like advertises a v6 address, but it's not working or responding well, the v4 connections themselves are a little bit slower. Actually, at the 90th percentile, quite a bit slower. And so having to use v4 on something that advertises dual stack connectivity usually implies that there's other brokenness or other issues with it. And even when we have hosts and servers that are only IPv4, and they don't have a v6 address to get to, even though the client does have dual stack connectivity, we see that is, particularly at the 90th percentile, measurably slower by over 100 milliseconds. So why would that be? And we don't really know all the answers. We just see this correlation. But there are a couple things that are playing into this that are possibilities. I can't identify in every case what it is. But one of the things is that IPv6 has fewer NATs, the network address translators, that pretty much have to be there for v4 connectivity because there aren't enough addresses for all the clients. So in the cases of NATs, you're going through more infrastructure. It may be less optimally routed. And we also see that the servers may have less optimal locations for v4 or less optimized routing to that. So these are just some of the things that may be in play. If you have other ideas of why you think this performance difference could be seen, great. But either way, the clients that are using v6 are benefiting. So that is a direct benefit to them using this. And beyond that, like beyond just what's good for the client, clients adopting v6 is a key component of the transition to IPv6 overall. And I think everyone working on network infrastructure of clients or servers or networks, can see that, as we run out of address space and have to put more and more NATs in for v4, it's beneficial to have an infrastructure that doesn't require that we do that. It's beneficial for the overall ecosystem to use IPv6, and clients actually adopting v6 and using it actively is a really key part of the adoption rate. So, connectivity on networks over v6 and servers supporting v6, it's a prerequisite. It's necessary to have the transition work, but alone, it's not enough. If clients aren't able to reliably and consistently use IPv6, it doesn't matter how much connectivity you have, it's not actually being used end to end. So we need a way to enable that. So the next thing I want to get into is, okay, so we like v6. Why not just always use it just, the moment I have v6 connectivity and I know there's an IPv6 address on the server, just use it, forget about IPv4, forge ahead, we know what we want to use. You could try to do that, you could just never look back, but there are problems there. IPv6 connectivity is sometimes broken, and when you have network or servers that say they support IPv6, but something is not working or something is slow, you can leave clients with very broken connectivity or very delayed connectivity, and it's not a good situation to be in. So, there are many different ways we've seen this break. You can have servers that have v6 addresses, but they don't ever respond on them, or they're very, very slow. You have networks that may be broken or slow. But there's a bigger point in here also, that from the client's perspective, anytime when you get back a particular address for a server and you have multiple options and you only stick on one address, that's a bad idea. We see, all the time, the server may be going down and it may be taking out of commission or being rebooted or something. And if you're unlucky and you get stuck on that, you're going to have a pretty bad day. So even separately from the v4, v6 split, trying multiple options and not waiting for timeouts is the best way to get a connection set up. Diving a bit more into different types of brokenness, I've seen a lot of different things over the years. Sometimes you have firewalls that are misconfigured, that are set up to work well for v4, but someone didn't go through and fix the firewall rules for IPv6. We've seen some particularly nasty things with terminating proxies, like that are terminating TCP as a performance acceleration that the network provides. And this is something that is completely transparent to the client. They don't know what's happening. And we've seen proxies that will terminate both v4 and v6 addresses. But if the end server you're trying to reach is IPv6, they will just black hole the traffic, and so you'll finish a TCP handshake and then nothing more will go through. Quite bad. And these are, bugs, these are misconfigurations, and oftentimes when they get raised, they do eventually get fixed. Sometimes it takes years, but so it's a slow process, and it's not something that we can really wait for, and we really don't want to block IPv6 deployment and adoption on those bugs. All right, so now let's get into the algorithm. What does Happy Eyeballs do? So let's talk about what that algorithm does. So the name, let's get into why does it have this weird name? So the meaning of this is that you want the eyeballs of the user, let's say they're loading a web page or they're using an app, they're doing something that requires internet connectivity. You want their eyeballs to be happy because the network connectivity is fast and it works across any network, and they just see whatever they want to get loaded snappily. So that's what we're trying to focus on prioritizing. And because we want IPv6 connectivity, because we think it's faster and it's better overall, we want to use it whenever we can, but we don't want to get tripped up by brokenness or bugs. So the overall algorithm flows like this, and this is based on what's in Happy Eyeballs version 2, which is RFC 8305. So you can read that for all the details, but I'll just kind of talk about the high level here. Essentially 3 steps. It's how you do your DNS queries. It's how you sort the answers you get back from the DNS queries. And then it's what you do with those to actually make connections and race them in parallel. So the first stage about doing the DNS queries, a couple different considerations here that the algorithm brings up that are not immediately obvious if you're just using get_attr_info or something like that. First, you can have a preference of if you have multiple DNS resolver addresses that you get back from the network. If you have a v6 and a v4 address, prefer using a v6 address for the resolver, but understand how to fail back if that thing is not working. And then when you're issuing queries, clients, if you have dual stack connectivity, you should be issuing both an A and a quad A query. Quad A query for getting IPv6 answers and the A query for getting IPv4 answers. So issue them in parallel with a slight recommendation to, because you have to send out packets in order, send the quad A first. And then when you get answers back, as you get quad A answers, which have IPv6 addresses in them, start using that for the next stage of sorting immediately. But if you get back an A answer first, so an IPv4 address, give a little bit of delay, like up to 50 milliseconds, to get the quad A answers as well, so that you have a pool of both IPv4 and IPv6 addresses. So then once you've received the addresses, you need to sort them to understand which ones that you want to try first. RFC 6724 gives an overall address sorting algorithm, and so we just rely on that. But we also, after doing that stage, calculate in historical round trip times. So if we've connected to particular subnets before, and if there's a large difference between 2 different subnets of one is much faster than the other, that should influence the sorting. And if Happy Eyeballs is assuming you have a preference for IPv6, and so you want to place, after you do all of your sorting, you sort an IPv6 address up to the top, and Happy Eyeballs version 2 specifically suggests that you sort 2 IPv6 addresses followed by an IPv4 address if you have multiple v6 addresses as options. And another key piece here is that if you have historical data showing that either on your whole network or for particular server address subnets, you have IPv6 brokenness, then you invert the sorting and you put v4 at the top, followed by IPv6. And so then once you've built that sorted list, you start to do connection attempts. And these are done in parallel, but not simultaneously. And I think that's very key. So we don't want to increase server load unnecessarily and have a lot of abandoned connections, but we don't want to wait for full connection timeouts. And so the timeout delay is based on the like the TCP retransmission timeout. So like the time when you would say maybe a packet was lost or maybe there's an issue, let's resend a packet. And that's usually quite short, and it's based on the observed network round trip time. And so it's not like a fixed delay of like, oh, just wait 300 milliseconds. That's too long, but it needs to scale with the speed of the network. And so you essentially have these cascading lists of connections going out. And as you start the next connection attempt, if you haven't finished the first one, they all continue going on in parallel, potentially retransmitting SYN packets, etc. And then the moment that one of those connections finishes, the race is over and you abandon all the other connection attempts. And I'll get into this a little bit more later, but it's also important to, if you're doing like an end-to-end TLS connection and not just a TCP connection, that's clear text, racing all the way through. So like letting the connection attempts be determined by the TLS end-to-end handshake completing is important because of things like I mentioned before of a TCP terminating proxy that may make you think you have a successful connection, but it actually doesn't have connectivity all the way. So that's the overall algorithm that has existed for years now and has been talked about. And I want to first, before we talk about the changes to the algorithm, get into the measurements of how well this works and what we see. So I'm going to look at some measurements that we've taken for how connections are observing their connectivity and their success rates for different address families, looking at essentially 3 metrics here. So this is how often is IPv6 available for connectivity on a network? How often of those networks does a server offer an IPv6 address that we can get to? And then for those attempts where we are doing both v4 and v6 address attempts, how often are we actually using IPv6 and not having to fall back to IPv4? And again, this is measured kind of in terms of how many connections the client sees, not in terms of how many networks there are, how many clients there are. It's just in terms of all the connections that clients make all bundled together. So here's the worldwide view. So if you start over on the far left and we look at the network breakdown, we see that almost half of connections, so 48% of connections, are being made on dual stack networks. So clients who have connectivity to both v4 and v6. About the same amount have v4 only, and there are about 5% who are on truly v6 only networks. So that's cool. So on the dual stack networks, the number of connections that are being made to servers that have dual stack connectivity is again almost half, so 47%, slightly less than half. But of those, so when we're doing happy eyeballs to those, we see that we end up using IPv6 93% of the time, which is great. So it means that almost all of the time when we have v6 available, both on the network and on the server, we use it. But it also means that around 7% of the time, which is definitely noticeable, IPv6 is either slower or it's potentially broken. And maybe the slowness is just being unlucky because a couple packets got dropped, but that's a significant portion. So it shows that our deployments are pretty good, and we do like using IPv6 a lot, but it's not perfect yet. And a 7% failure rate, if we were blocking on that, would be very user noticeable and not acceptable. So looking at like just the US numbers, because those previous numbers were worldwide. In the US, we see more than half of networks on a support dual stack connectivity. That's at 54%, and slightly more than previously also have v6 only. So we see 6% of connections on networks like that. And of the dual stack networks, the servers that we talk to are over half dual stack. So they have v4 and v6 addresses. And we also see that the rate of v6 success is higher. It's up to 95%. So only 5% of cases have brokenness or slowness that causes falling back. And then since, for this particular audience, we're talking a lot about the deployments in India. Pulled up some stats here. So definitely very interesting things, and I'd love to hear people's thoughts about why we may see some of this. So we see a lot of connectivity, at least of the connections that we're observing from these devices, has v6 available. So 56% of networks, and we see a bunch of networks that are v6 only, actually. And then as far as availability of v6 on the servers that people are going to, slightly lower, so only 46% are dual stack, but there also is a significant number of connections that are being made to v6 only hosts, which is pretty interesting to see some servers that even on a dual stack network are only offering v6 connectivity, or at least the A queries are not coming back. But then when we look at the overall success rate of IPv6, it is a little bit lower, so it's only 91% of the time. And so there's 9% of cases where we have to fall back to IPv4 due to slowness or brokenness. So yeah, I'd love to hear people's thoughts on this, but it seems like there's pretty good growth in the connectivity for v6, but some of the issues about connectivity actually working may be lagging slightly. And so in these cases, the happy eyeballs algorithm is more important to actually get a good user experience out of it. So overall, what I want you to take away from this part is that happy eyeballs as an algorithm allows us to essentially like explore the space of how much we can safely use IPv6 and use it as much as possible, as soon as possible, even if there's brokenness. So it's a way to not get tripped up by potential issues. Now, there is a flip side to this, and this has been raised in several IETF discussions over the years, is that using an algorithm like this can hide brokenness. If you have cases where a network bug or a configuration bug on a server would cause issues for IPv6 and clients didn't fail over seamlessly, people would complain more and you'd notice it and you may be able to fix the bug faster. So there is a trade-off of having a good experience for users and being able to identify the brokenness quickly. And this is an open, ongoing discussion. I do believe that, fundamentally it is important to have the algorithm that having the users be able to use IPv6, as opposed to saying the moment I turn on IPv6 on my network, 9% of my connections are failing. Like that's not acceptable. And that would actually hinder the overall deployment of v6. But I think there are ways that overall the internet community can look at trying to do better measurement of networks and servers to see how often the fallback to IPv4 is needed for cases like what we've shown. And there's discussion and suggestions about clients potentially automatically reporting issues or having some way to give feedback. And we need some protocol mechanisms to do that and do that in a privacy-preserving way. So this is one area that I'd love to see engagement on. But reporting brokenness isn't the only area of new development and open discussion. And the reason, one of the reasons for this talk is that we've been recently proposing a new version, a version 3 for Happy Eyeballs, that is motivated by several changes in internet protocols that have essentially pushed us to update that RFC 8305. So a lot has changed in the past 4 or 5 years. We have a major new transport protocol that's being used quite often. That's not TCP, it's QUIC. So that does slightly change things. We see more prevalence of IPv6 only networks and also techniques and mechanisms for dealing with IPv6 only. We see more clients using encrypted DNS either to the local network or to a public resolver, and that has some implications on how we get the addresses back. Potentially, if you're talking to an encrypted DNS resolver that is not local to your network, but your network is IPv6 only, and you have a NAT64, you may need to look up the prefixes to do v4 to v6 translation locally or differently. You may be getting back v4 and v6 answers, but only have connectivity over one address family. So it does impact the overall algorithm. And one of the biggest ones here is this next one, that we have new DNS record types called service binding records, or SVCB, and there's a particular form of that record, which is the HTTPS record. And this dramatically changes things and actually gets back to what some of the last talk was talking about for getting addresses simultaneously and having priority from servers. And then we also have new considerations for how the connectivity is related to application level protocols and security protocols that may be available on some addresses but not others. So I think one of the most interesting to dive into and introduce you to is this service binding record, and this is a very new RFC 9460. Definitely recommend reading up on that if you're interested in some of these new deployment types. So this is a new DNS record type that clients will send queries for in parallel with A and Quad A. So it's not just clients sending A and Quad A queries, but now they're saying A, Quad A, and usually HTTPS queries all at the same time. And these records can tell clients about the priorities of different services that are available. It can give in the response both v4 and v6 address hints, and it can even tell clients about which protocols are supported. So like which versions of HTTP and whether or not they're over QUIC or TCP. So these are some of the things that we're talking about in version 3, and we've talked about at the last IETF meeting in Prague. So some of the changes we have to make to the algorithm. So the first stage is doing the DNS record queries. And so now we query service binding Quad A and A all in parallel. We then, for the sorting stage, we can use the priority associated with a service binding record and how it's associated to A and Quad A records to rank things differently and to use that priority to leverage hints from the server more often. And you have cases where you have A and Quad A queries that are associated with a service binding record, and sometimes they're not. And you have to know how do you fold in the ones that aren't associated. We recommend putting them at the end. And you also have information in the service binding record, like what we're listing here is ECH. This is TLS encrypted client alone. So you may have new security options. And if you have new security options with one service but not the other, potentially because you have multiple CDNs that are providing connectivity, maybe the client should prefer the more secure option. Different considerations to have in the algorithm. And then also because now we have potentially multiple transport protocols, we have TLS over TCP on one hand and QUIC on the other hand. It's even more important that the connection establishment phase, where we're waiting for the connectivity to finish, is racing all the way through the secure handshake, not just the TCP level handshake, but all the way to TLS, since QUIC is merging those two into essentially one, where we have a secure handshake and a transport handshake happening in one round trip. So as I mentioned, QUIC is definitely a big change here. And the original algorithm in RFC focused a lot of its values for the timers about when you would stagger connection attempts based on TCP retransmission values. So if you have a stack that's also using QUIC, you would want to stagger connection attempts after QUIC based on when QUIC would be retransmitting its packets. And so you want some knowledge and insight into the actual protocol stack and the overall timing to influence this algorithm. And since servers can be available over both TCP and QUIC, you essentially have another layer of racing and branching which options you have. And so you have both protocols and addresses now that are all folding into the mix. So there are different ways you can try to generalize for QUIC. You can prefer services that have QUIC support in the service binding record being explicitly called out. And this, in the same way that clients may prefer IPv6 because it's going to be better infrastructure, faster infrastructure, QUIC also has many benefits for performance. It's going to have improved delivery, congestion control. It's a faster handshake time. It can support migrating between multiple interfaces. So it's definitely beneficial for the client connectivity. And so there are ways in which the original algorithm needs to be updated to not just mention TCP, but talk about how we fold in QUIC here. So those are the main changes and highlights we see here. And so I wanted to call out, how, if you're interested in this area and you want to influence how the IETF is standardizing these algorithms and trying to help promote the deployment both of IPv6 and also other protocols that may be enhancing the performance of connections for clients, how you can engage. So previously at IETF 118 in Prague, we discussed Happy Eyeballs version 3 at both the v6 ops group and the TSVWG, one of the transport working groups. And up at the upcoming IETF in Brisbane, we've requested a slot at a new all dispatch session where it's essentially posing the question to the IETF of where should this work happen? Because as you've seen, while this work is very much rooted in IPv6, it has so many relationships to other protocols and technologies. It's very much related to DNS, it's related to QUIC and security, and they all have implications about how can we continue to roll out this algorithm and be promoting v6, but also be taking into account so many other concerns. So we're going to be posing the question of, does this continue to belong in a group that's focused on IPv6, or does it need a new home? If you go to the draft, there are also links to the GitHub for doing development on the draft, and so you can file issues and pull requests there for changes. And we also have some threads from a little while ago on the IETF v6 ops mailing list, and so you can engage there. And with that, we can go to questions.
Thank you so much, Tommy. This was just great. And so please put your questions into the questions window. I see there are some coming, and I see that Mike has a question too, but I'm going to burst in there. Drew, could you unmute Mike if you get a minute? So Tommy, I think I may have, and I think, yeah, it looks like Davey. Oh, yeah, you got a lot of action coming here. So I'm going to throw this in, and then I meant to do this. I meant to put a note into the v6 ops email list. Is if you wait until the end of the TLS session, what is going to happen? More than likely, once you have post-quantum, is the post-quantum handshake, because it's so much bigger, and the keys are bigger, the certs are bigger, it's always going to be, it's always going to not win. And so that's another whole question we need to talk about. And as I say, I meant to put it in, and actually on Thursday, I'll pose this question also to, because we have Cloudflare and Nokia speaking, so we'll talk to them too. Yeah.
Just as a quick comment on that, and I didn't go into too much detail about what it means to have the connection attempt race go all the way through the TLS handshake, but it's not quite as simple as just saying, we set this initial timer for 1 or 2 TCP retransmission times, and then we keep kicking things off. That, to your point, like the handshake may take more time, and also it would be inefficient because we'd likely kick off too many attempts, even though the first one will eventually succeed. So the way the algorithm, when you have the kind of like the end-to-end TLS working, is that let's say you start this initial connection attempt to the first IPv6 address, and you set a timer of 1 or 2 TCP retransmissions before you start the next, or the v4 address. If in that time your transport connection, your TCP connection completes, then we don't immediately cut off the racing logic. We don't say this is our one winner, but we do push out the timer. We say, we've made progress. We think this is a good option. So let's extend the timer, and you have to choose a value to extend the timer to say, okay, now I'm doing TLS. I'm going to extend my timer by another 1 or 2 round trip times. And then you give TLS time to finish. And if it gets stuck, then you have an opportunity to now fall back to one of your other options, your v4 address, or your other v6 addresses. And I think you bring up a great point with post-quantum, that those may take even longer or have more packets in flight. And so that's an opportunity to make the algorithm nuanced in how it pushes out the timer to say, I haven't finished my TLS handshake, but I've started getting back some of the information. I see I'm making progress. And so essentially, as long as we're making progress, we can extend the timers and not fail over. But if we ever get to the point where we're stopping to make progress and we detect a stall, then we want to have these other options in our back pocket and be able to fail over to them.
Oh, great. Thank you so much. And as I say, I mean, I could talk for hours, but I'm not going to. So let me answer the question from the question window from Shraddha. And so Shraddha is asking, when there's IPv6 brokenness, is there data on how many times it's an application layer problem and how many times it's a network problem?
That's a very, very good question. So the data we were talking about here for brokenness really is primarily looking at just like the transport or maybe TLS handshake level connectivity. It's not going into like a true like an HTTP level, et cetera. So oftentimes I would say it is biased towards catching network connectivity brokenness or some server deployment or server configuration brokenness. But between those, it's really hard to tell from the client often, what went wrong. If I'm sending out my TCP SYNs and I don't get a response, or even if the TCP handshake completes, but then larger packets aren't getting through, it's really difficult to know that. And so I guess turning it back to this audience and the broader community, I think these are some of the areas where we would love to see better measurement. And getting back to this notion of like hiding brokenness, if we want to complement Happy Eyeballs with more techniques to do measurement to identify problem areas, we need ways to identify which layer is broken or to triangulate that a bit better. So
okay, I will not do any more because like some of the testing we've done on CDNs and cloud, I'm going to tell you something. I'll just say some CDNs, shockingly enough, prefer IPv4. I'll just leave it at that. So let someone else talk. Michael, do you want to say something? Maybe you can, or Davey. And I see another question.
If it's this Michael, can you hear me?
Yep, we can hear you just
okay,
fine.
Great. First off, Tommy, fantastic stuff. We're all a little smarter now thanks to your presentation. Great information. Thank you so much.
Good.
I had the same question that Sveta did, and I took your answer to mean that we need more detail, more granularity there to figure out why these sessions are failing. Because I was going to focus on your slide with the 7 and 9%. I found that really fascinating because that doesn't sound like a lot, but if it's in my network, it's a hell of a lot. So yeah, I think that's worth pursuing. And Delaney, I agree with you. It's painful, but I think we do want to put the time and effort into this. This is important stuff to figure out. So thanks on that. And one other question I had was, we were talking about all the timers like the DNS delay timer and that. Do users have the ability to massage those timers in their own networks, or should we leave that alone?
I mean, at least on the implementations we have, we don't have user knobs for those. But hey, if someone's building other implementations of the algorithm, particularly for people who are more inclined to do research on the network, having the ability to tune those and do experiments across which ones work better would be fantastic. So again, kind of like a call for if people want to work on that.
So it is possible. We need to find out when and where and do it responsibly and all that. But I was expecting you to say no, keep your hot little hands off of that. But yes, it sounds like it is possible and maybe even advisable if you do it right.
Um, right. So I mean, it's not, like on an iPhone, there's not a way that a user could do that. But I know a lot of curl has implementations of happy eyeballs, and so I think different implementations may offer different knobs, and I think as we see more people implementing V2 and hopefully V3 in the future, making sure that they implement them with the ability to help researchers or people working on measurement check the values and try out different things. I think that'd be really important.
Good answer. And Nalini, if we do actually test this, then we could use curl and maybe even play with this and find out even more. So anyway, good stuff. Thank you. That's all for me.
Great.
No, totally, Mike. So Davey, Drew, if you get a chance, might you unmute Davey? We'll let him get a word in edgewise.
Okay.
Yep, go ahead.
Tommy. Okay, can you hear me?
Yes, we can hear you just fine.
Okay, Tommy, thank you very much for your presentation. I'm a fan of happy eyeballs, right? If you listen to my talk, I introduced that part. It's really the big concerns for the applications, especially when you have more than billion users, right? And my question, I'm very interested on the pictures that with 3 circles, portions. Can you roll back to one of them? For example, the worldwide circles.
Sure.
I want to. My question is that the first circle. The first circle is the dual stack network, right? How you divided in the second circle and the portion? What's the difference between the yellow and the green if it already belongs to the dual stack network?
Right. So the first circle on the far left is just looking at, for any particular connection, what percentage of connections are on networks where the client has been assigned both a v4 and a v6 address and has connectivity. And so, it is only on those networks that the client would be issuing both an A and quad A query to learn about both v4 and v6 server addresses. On a v4 only network, we'd only learn about v4 addresses. On a v6 only network, we only learn about v6 addresses. So that's why we want to zoom in on the ones that have dual stack connectivity. And then for these,
when you observe you observe the queries from users to your backend server of Apple. I mean,
this is measured from clients. So the client is saying,
okay,
I have a v4 and a v6 address. I am sending out an A and a quad A query for this 48% of the time. And so it means that for the clients that are sending out both an A and a quad A query for the connection, worldwide, 53% of them only get an answer for A and get nothing back for the quad A query because the server is publishing A answers. But 47% of the time, they receive both answers for A and quad A. And therefore,
so it depends on the domain, right?
Exactly.
It depends on the domain, right?
Yes. So this is saying, and this is looking at connections, and so it's not the percent of domains that support dual stack connectivity. It's the percent kind of of popular domains, like things that people are actively using. So if you scanned every domain you could find, I'm sure the number would be quite different. But this is in practice, 47% of connections on dual stack capable networks are to servers that have dual stack connectivity advertised via.
So the second the pie, the second pie is reflecting the general IPv6 adoption on the website. Is that okay? Is that right?
Websites
it's not to reflect
other servers that may be.
It's reflect the radius of the domain, not to the client, right?
Correct. Yes, exactly. The first one shows essentially the network configuration state. The second one shows the server configuration stage.
Servers. Okay.
Third one is how often it's
Mm.
successful from the client's perspective. Yeah.
I see. I wonder. Yeah, I wonder if you can. I will send mail to you. Maybe you can send me a picture of China situation.
And you know, in the past, like you know, this is data that we've shared before at there's a MapRG research group that talks about measurement TF, where in the IRTF. And you know, we could come back to that group and kind of you know, share more different country graphs of what people are interested in. For this audience, you know, I thought it was great to look at India.
Okay. Thank you. Thank you.
So Davey, I'm going to put a plug in. You should start coming to the IETF. Would love to see you there, and we can have lots of talks. You know, I'll buy you dinner if you come next time.
Thank you. I participate IETF before I went to Alibaba.
You guys have money. Alibaba to tell him to send you. Yeah. So let me give you one more question from the chat. So is hostility by the middle boxes, for example, outright blocking of Quick to force fallback to TCP, is that a concern for you?
I mean, yes, and I think that's why Happy Eyeballs is so important as an algorithm, right? Because right, I think it's probably more likely to see hostility towards Quick or encrypted client hello than it is hostility to IPv6. But from the client's perspective, intentional brokenness and accidental brokenness look the same. And you know, this algorithm of being able to be resilient to brokenness while still having preferences for better protocols, it is the same. And I think it's a principle that's worked out really well. And so you can do the same thing for Quick that you do for IPv6. Try the Quick attempt first. If it looks like it's not getting through because you're hitting retransmission timeouts, try TCP. And the way you fold that into the whole v4, v6 racing algorithm gets more complex, but it's principally the same thing. So yeah, I think Happy Eyeballs is the key to getting around a lot of these issues.
Yeah, no, very, very interesting. And I know we've certainly, from the NITK implementation, the girls have certainly looked at Happy Eyeballs and kind of what's going on. So let me thank you again, Tommy, for presenting. Very, very interesting talk. And Davey also, yes, thank you guys so much. You know, you can see from all the discussion and the questions that we really, really enjoyed having you. Please, let's keep in touch. There is an IETF 119 coming up in Brisbane soon enough. Hope to see many of you there. There's a workshop at NITK. You can send myself or Mohit or Dhruv a note, and we would love to see you in India. It will be held live. It's an in-person event in India. Would love to see you there. Tomorrow is the network observability track, and quite a few people will be speaking there, including our own Mike Ackerman and quite a few other people. So thank you guys so much, and we'll see you tomorrow.
Thanks, everyone. Bye. I'll stop the recording.